So this is our second topic in Unit 15, 16, Problems in Measurement here. And what we want to look at today is we want to look at some problems having to do with perimeter and surface area, or just area of shapes. In particular, by the end of these lessons, what you need to be able to do is to know how to determine the perimeter and the area of a composite shape, and as you're doing so, be able to apply the Pythagorean theorem in order to come up with the lengths of sides that you might need to get the perimeter and area. And before we get into the actual examples, just let's remind ourselves, what do we mean by a composite shape? And a composite shape is composed of two simple shapes, or three simple shapes, or more simple shapes that have been put together. So let's just say two or more simple shapes. And when I say simple shapes, I mean things like squares, triangles, or circles, things that the shapes that you're familiar with. Simple shapes put together. Now, as we're going through these questions, it's probably a good idea to have that formula sheet that you got from your teacher handy, so you can use them to look up any of the formulas for area that you need. So let's just jump in, and in the first part of the lesson, we'll just look at how you would find the area. So I've got two composite shapes, one on this slide and one on the next slide, and what we're going to want to do is find the area of our two shapes. First thing you want to do when they give you a composite shape like this is figure out what are the two shapes or more shapes that this is made up of. So I'll just say that that's step one. Identify the shapes. So what two shapes do we have here? Well, we've got a half circle, okay, up here. We'll call this, I don't know, maybe we'll just label it number 1. And then down here, shape number 2, we have a trapezoid. So I'll do the trapezoid down here. Trapezoid. And if we want to find the combined area of these two shapes, we need to find the area of each individual shape, the area of our half circle, the area of the trapezoid, and then add them up. So the next thing we should probably do is figure out what formulas we're going to need to find each of these areas. So if I look this up on my formula sheet, I see that for the area of a circle, my formula is pi r squared. But I have a half circle, so I'm going to want to divide that by 2. And for my trapezoid, I looked that up on my formula sheet, and it says there that my area is A equals A plus B times H divided by 2. So I've got the formulas that I'm going to use, even if I'm not sure just exactly what to put into them yet. And that's the next step, number 3. We're going to sub in numbers to these formulas to get our areas. Now this is sometimes the tricky step, because we're not always given all of the numbers that we need to sub in. So let's take a look first at our half circle. Pi r squared divided by 2. Well, I know pi is 3.14. I need my radius, so I can square it, and then I can divide by 2. Now, what is my radius? Well, if I look up at my half circle here, I see a line that goes all the way from here to here, labeled as 6 centimeters. The radius starts at the center of my circle and goes out to one edge. So if this distance all the way across is 6 centimeters, my radius has to be 3 centimeters. So I can put 3 in here, and then I can work out what this is. So that's step 4, find the areas. So let's see, I punch this into my calculator, and I get 14.13 for the area of my half circle. Now I move on to my trapezoid. Let's see. Area is A plus B times H divided by 2. Well, H is this distance from the bottom up to the top here, so that is going to be 4 divided by 2. what are these A and B's? Well, A is the top of my trapezoid, and B is the bottom. So A is this distance from here to here. That's going to be 6. B is the distance from here to here. That's going to be my 10. And now I just need to figure out what my area is. So I do the calculation in brackets first. 6 plus 10 is 16 times 4 divided by 2. Put that into my calculator, and I get 32. So the area of my trapezoid is 32. The area of my half circle is 14.13. So my total area, I'll just say A total, is going to be that 14.13 plus that 32, or 46.13 centimeters squared. And that would be my final answer. Okay. So that's step 5. Add them up. Okay. So let's take a look at the next example. Here we have a shape, okay, composite shape, 2 simpler shapes put together, and again, we want to find the area. So let's just list our steps here down the side. We're going to identify our shapes. Once we've identified them, we can look at what sort of formulas we need. We can sub in the numbers to those formulas. We can find the areas, the individual areas, and then 5, we can add them up. And I'll just switch colors here. So, what 2 shapes do we have here? Well, if I draw a dotted line across like this, it makes it a little bit easier to see that up here, shape number 1 here is going to be a square, because these little tick marks here and here tell us that all of these sides are the same length. Okay? So that's going to be my first shape, and down here, obviously, I have a triangle. Okay? So my 2 shapes are going to be a square and a triangle. Square and triangle. Okay. Now I'll just take these numbers off my diagram here to give myself a little bit more room. So square, let's see, I need the formula for the area of a square. That's going to be, I can use the rectangle formula, length times width. Okay. And for the triangle, I know that my formula is going to be area is 1/2 base times height, or base times height divided by 2. And let's start working on putting in the numbers here. So let's go back up to the square here. I need length times width. Well, these tick marks again tell me that all of these sides are the same length. So I know that my length is going to be 6 times 6. Length times width is 6 times 6. So my area is going to be 36 centimeters squared. So we've got our square done. Now let's look at our triangle. Area is 1/2 base times height. Okay, so my base is, my triangle is upside down, so my base is along here. I know this is going to be 6 centimeters because that top thing is a square. My height is from the base all the way up to the vertex there. That's the height. Now this gives us a bit of a problem because we don't know what the height is. We're not told this. But by putting that dotted line in there, I have made a little right angle triangle with my height, this length along here, and this side here that is on an angle, the 4 centimeters. I can use that right angle triangle to figure out what the height is. So if I'm applying the Pythagorean theorem, let's see, I would label my triangle. This is going to be my C. I'll call the height A over here. I'll call this side up here B. And I'm going to use C squared equals A squared plus B squared. I know that C is 4, so I can put 4 squared. A is my height, so that's H squared. Now, what is b going to be? Well, if I've got two b's here, okay, I've got this one base of my triangle that goes all the way across, that's 6 centimeters. The little red b only goes from here to here. It's the base of this smaller right angle triangle. So that's going to be half of that 6. That's going to be 3 centimeters. So now I can solve this using the Pythagorean theorem. I'll get 16 equals h squared plus 9. I can subtract the 9 from both sides to get h squared all by itself. Subtract 9, subtract 9. And then I'm going to have, let's see, 16 minus 9 is going to be 7. H squared. So h is going to be root 7, which is, put this into our calculator, 2.65. So now that I have h, I can use that over here in my triangle. My base is the 6 centimeters all along the bottom of the triangle. My height is the 2.65 that I just calculated, and then I've got to divide that whole thing by 2. So 6 times 2.65 divided by 2 gives me 7.95. When in doubt, always just keep 2 decimal places. So now all that's left to do is step 5 here. Let's add these things up. So my total area is going to be that 7.65 from my triangle plus the 36 from my square. It gives me a total area of 43.95, and it's an area, so it has to be centimeters squared. And I put a box around it to show that that's my final answer.